Hey everyone, this is our lesson on naming and formulas for acids and bases. And by the end of this lesson, you should be able to interpret the name and formula for compounds using IUPAC convention. Before you get started, though, you may want to review ionic naming because that will play a part in bases for sure and part of what we look at with acids. So let's talk about naming acids without oxygens. So first of all, an acid itself is a substance that contains hydrogens and will form H plus when it's dissolved in water. That's what makes it an acid. But sometimes the way we name them depends on if there's oxygens. So it could contain an oxygen, which means a polyatomic ion is present, or it won't, which means it's just a regular anion off the periodic table. So when we're looking at if we should apply these rules or not, we first have to make sure if there is an H out front. If there is, that's a dead giveaway that we are dealing with an acid. So you figure out the stem of the anion name. So for instance, if chloride is your anion, chlor is the stem. And from there, we have to kind of take that a step further on some examples. For instance, the majority of the word is the stem. Sometimes the entire word is the stem. For instance, sulfur, the whole stem is sulfur. So just kind of be prepared for that. Phosphorus, the whole stem is phosphor. So just know that as we go into some of these. So when we have just an anion, so basic off the periodic table, 2 capital letters, and that's it. So that's another way to tell if you're dealing with an anion or a polyatomic, only 2 capital letters. You will name it as hydro, the stem of your anion, ic acid. So if it was HCl, chloride is my stem or my anion, so chlor is my stem, hydrochloric acid. Okay, so let's try this one together. HI. So first we have to determine the anion and the stem. So our anion is iodide, and my stem would be iode. We follow the rules like we were just talking about. So it's hydrostemic acid, which means it becomes hydroiodic acid. So just remember that's your basic steps there. And then I want you to pause the video and I want you to name the following. So now let's talk about formulas for acids without hydrogen. So it's just H plus the anion based on whatever the stem is in the name. Sometimes my screen doesn't like to work. Hold on. And you write it as ions first so that then you can balance the charge. So this does play like ionic compounds. Remember, acids and, well, really just acids, they are made up of only nonmetals, but they ionize in solution like an ionic compound. So we do have to pay attention to charge. We do have to pay attention to balancing those charges. So the way you can do that is you just throw on as many H pluses as you need to cancel the charge on the anion. Because remember, H plus is a +1 charge. Okay. I guess that was all on that screen. So we're going to try to write the formula for hydrobromic acid. So we just write the symbols and their charges. We know it's an acid because it's in the name. So you have H plus out front. Brome is my stem, which would be for bromide. So Br minus. As you can tell, this is a +1 and -1. So they are equal but opposite, which means they will cancel. And my formula is HBr. And that's it. So you go ahead and you try this example at the bottom. So now let's talk about naming and formulas when an acid does have oxygen present, which means we are looking at a polyatomic ion. So we have to look at the we have to look at the reference packet to see which polyatomic ion is present. Remember that the 8 stem on a polyatomic means more oxygen. So 8 is great. So we've got more oxygens. When you're going to name one that has an 8 polyatomic, you use the stem of the polyatomic and ic acid at the end. Okay? If it is the ite polyatomic, so has less oxygens, you use the stem and OUS acid at the end, or us acid. The reason we say 8 or ite is because sometimes we have polyatomics that have the same stem element at the beginning, and that can throw things off. So if you have nitrate or nitrite, it's based on that number of oxygens. Nitrite is NO2, nitrate is NO3, which means HNO3 would be nitric acid, HNO2 would be nitrous acid. Okay, so 8 is great, ite is mite. That's how you can remember. Mites are little, so less oxygen. Great means bigger. One big thing to know about writing these names is there is no hydro in the name. So do not put hydro out front. It doesn't have that because it's a polyatomic. For the formulas, you follow the same rules as you did with an acid without an oxygen. So you would just write down the ions with the charges, add on as many hydrogens as you need to balance. Okay, so if you want to pause, let me X out of my video here. You can pause and kind of look over this before you move on to the examples. All right, so let's go through these. So we're going to give the name or the formula for the following: H2SO4 and nitric acid. So first, let's look at H2SO4. We're going to write the name for this one. So first, we have to determine the anion. And from your reference packet, you'll see that SO4 is the sulfate ion. So remember, we've got that 8 ending there, okay? And that is important for how we name. So then we use the rules for naming the 8 polyions, which means we're going to take that sulfate and we're going to turn it into sulfuric acid. No hydro. So now let's try to name nitric acid. I hate when the screen doesn't work. I'm sorry, guys. So nitric acid. And we determine the acid, the type of acid that we have. There's no hydro out front, which automatically means we're dealing with a polyatomic. And since it has the ic ending, we're dealing with an 8 polyatomic. So you're going to go on to your reference packet, find the 2 nite polyatomics that you have. Since we know we're dealing with the 8, find nitrate, which would be NO3 minus. And since it's NO3 minus, we combine that with H plus. Here, let me X out of this again so you can see the whole thing. They are equal but opposite, so you make a charge of you make a formula of HNO3. So go ahead and pause your video and try these 2 examples here. But I will tell you before you pause the video, pay attention to the ending there. So now let's talk about naming and formulas for bases. This is identical to ions, ionic compounds, so it's not any different there, but as a quick review for that. I don't know why this doesn't want to work all the time. There we go. So we're going to take a cation and we're going to use hydroxide as our anion, because a base is a compound that when dissolved in water releases a hydroxide, which is OH minus on your polyatomics chart. Oh, yeah. So you just find the cation that goes with the OH minus. So we're going to try to name NaOH here. We use the rules for naming ionic compounds with our polyatomics chart. So Na, we know is sodium. OH is hydroxide. We don't use prefixes. We don't do anything like that with ionic. So we just name it the way it is. Remember, with polyatomics, you do not change the name. And since OH is a polyatomic, we leave it. Okay. So you're going to try two things. You're going to try to write the name and a formula for these two examples here. Remember, treat these like ionic, so you will have to balance charges if needed.